Yeah, good evening. Good evening, everyone. Good evening. Good evening. Good evening, everyone. Yeah, let me know audio video okay or not. Everyone, let me know audio video okay or not. Everyone know audio video okay or not. Before going to start. Can we start? Yeah, Ayan, can we start? Yeah, good morning. Sorry, good evening. Good evening, everyone. Likit saying that good evening. Yeah, perfect. Good evening. Good evening, everyone. Good evening. Can we start? Ayan, can we start? Okay, perfect then. Perfect. I think we can start. Yeah, we can start now. Thanks for everyone. Thanks for everyone. Let's start. Yeah, I'm starting now. So let me start it. Yeah, I'm starting. So the problem is the next problem. Next problem is please take care. Next problem is please take care. So I think today date is I think 31st. 31st 7/25. So remember one thing, whether you like or not, whether I will like or not, date will keep on change. Whether you like or not, whether I will like or not, it doesn't matter. Date will keep on change. So my request to all the people, please keep on study, please keep on study, please keep on grow. Please keep on study, please keep on study, right? Keep on increase the knowledge. That is the only one which can save you. So I'm starting now. Everything ready. I'm starting now. Today date is 31st 7/25. I'm starting. So take the first problem of today's class. P. Good mobile phones are not cheap. Q. I think P. Next one is Q. Cheap mobile phones are not good. Good mobile phones are not cheap. Cheap mobile phones are not good. Right? Not good. So until now, fine. Right? Next one. That is a PQ. Next one. L. P implies Q. M. Q implies P. N. P. Just wait. I think n is going to be just listen carefully. N is going to be P double implies Q. These are the four options. These are the four options. These are the four options. Right? Next one. Which are valid? Which are valid? Which are valid? Option A, only L. Option B, only M. Option C, only N. Option D, these are the four options. P is good mobile phones are not cheap. Q is cheap mobile phones are not good. L is P implies Q. M is Q implies P. N is P double implies Q. Which are valid? Which are valid? Valid means which are tautology. Which are tautology? Valid means what? Which are tautology? Which are tautology? Right? So four options are given. Please, can you try this? Please, can you try this? Everyone try. Everyone try. Please try this. Everyone try. Yeah, go ahead. Everyone try. Good mobile phones are not cheap. Q. Cheap mobile phones are not good. L. P implies Q. M. Q implies P. N. P double implies Q. Which are valid? Only L. Only M. Only N. L, M, N are true. It's a very interesting problem. Let's see how many people will give answer. Let's see how many people will give answer. Everyone have to try. Everyone have to try. Don't sit idle. Someone is saying all are tautology. Someone is saying that all are tautology. Someone is saying all are tautology. So let's see one by one. Let's see one by one. Someone is saying all are tautology. Let's see. See everyone. Let's see everyone. Let's see everyone. So good mobile phones are not cheap. Assume that. So he's talking directly mobile phones only. He's talking directly mobile phones only. But here the major thing is good mobile phones are not cheap. Cheap mobile phones are not good. So I think I can say right, good mobile phones, which is G, are not cheap. So cheap means C, not cheap means negation. So according to the given problem, if something is a good mobile phone, then it is not cheap. Cheap means C, not cheap means negation C. Same. Cheap mobile phones, I think C. They are not, then they are not good. Good means G, not good means this one. So it will goes to, if at all it is a cheap mobile phone, it is not good. Good mobile phone is G. If it is a good mobile phone, then it is not cheap. If it is a cheap mobile phone, then it is not good. I hope no one is having doubt till now. I hope no one is having problem till now. In my opinion, no one is having problem till now. Okay, I think if you observe clearly, see this one. If you observe clearly, to this one, right, to this one. If I write the contra positive means first left one right, right side, right one right, left side. So contra positive means reverse both of them. Reverse both of them, then keep the negation. If you reverse the left as right, negation C becomes C. If you keep the right as left, negation G becomes, sorry, G becomes negation G. So what I mean to say is, right, I think first statement P, statement Q, both are equal. One is contra positive to another. They both are equal. Contra positive. They both are equal. Contra positive. First to do converse, next to do inverse. First to do converse, then do inverse. Inversion means keeping negation. Conversing means swapping left to right, right to left. That is called contrapositive. First to do converse, next to do inverse. That is called contrapositive. When I do the first statement contrapositive, I got the second statement. Means I think first one, second one, both are same. Remember, first one, second one, both are same. When you say both are same, if you want, you can verify also. If two people are same, see this one. Two people same means what? Can you see this one? Two people same means if P is true, right? Q also true. So I think a true implication true. True implication true is true only. If at all P is false, then Q also false. False implication false, right? True only. So what I mean to say is, I think L is true. It is a tautology. So I think whenever both are equal, you swap the order also. Same. It is also tautology. Whenever both are same, you know very well. What is the double implication? What is the double implication? If both are equal, it is a true. If both are equal, then it is true. So this is also right. So L also, M also, N also. All three people are tautology. All three people are tautology. If two people are equal, definitely one to another. Implication also possible, right? Double implication also possible. Implication also possible, double implication also possible, right? So it is a tautology. It is a valid. Which are valid? So only L wrong, only M wrong, only C wrong. So LMN are true, LMN are true, LMN are true. It's a very good problem. If you have small doubt also, you can ask me. They given some data and they're asking which are valid. Only L. No. If two people are equal, let us in the two people P and Q. They both are equal. P implication Q is a tautology. I given the example. Why? If P true, Q also true. True implication true. If the P false, Q also false. Right? False implication false, which is going to be true. So it is a tautology. There is no chance of TF. There is no chance of TF. If the left true, right also true, which is true. If the left false, right also false, which is true. Right? I think everything is fine now. I think everything is fine now. Let me know. Fine. And one more thing, if at all both are true, if at all both are equal means left true means right also true, means both are same. If both are same means, so try to remember implication definitely tautology. If both are same, left side, right side, both are same. Double implication is a tautology. Because both same means it's a true, which is a tautology. I think no one having any objection here. I think no one having any objection. Little objection also, please let me know. If you think that small objection also there, please let me know. Contrapositive of Q is P. Contrapositive of P is Q. Exactly. Exactly. Little doubt also there. Little doubt also there. You can ask me. Anyone having objection? I am saying no objection. Tarab, do you have any objection? Tarab, do you have any objection? Yella, do you have any objection? Yella, do you have any objection? Likit, do you have any objection? Let me know. Likit, do you have any objection? Let me know. Anyone having small objection also, let me know, so that we can go to the next one. So that we can go to the next one. So that we can go to the next one. Anyone having any objection? Sir, I have this doubt. You ask me, I will help. Sir, I have this doubt. You ask me, I will help. Everyone, please careful. Everyone, please careful. Yeah, perfect. If you are comfortable, please try to understand. If you are comfortable, I can move to the next problem. I am moving to the next one. You are absolutely fine. I am moving to the next one. Can you see the next one? Can you see the next one? I am moving to the next one. Can you see the next one? So I think from these some conclusions, from these some small conclusions are there. I am writing. Can you see everyone? Everyone remember. Instead of saying next example, I can say note. Instead of saying example, I can say note. What is that note? Remember, from this problem, you have to understand this one. P implies P. It is a tautology. It is a valid statement. P implies P. If the left true, right also true. If the left false, right also false. Means TT or FF. So it is a tautology. This is the valid statement. Right? Two. And one more thing. PRQ. Careful, everyone. If P true, PRQ also true. If the left true, definitely right also true. There is no question of left true, right is false. There is no question of if left true, right is going to be false. No way. If left true, right also true. Right also true. If you want, you can verify. It's a very nice way. It's a very nice statement. Same way you can write like this also. If Q true, PRQ also true. And one more, fourth one. P and Q true, then P also true. P and Q true, then Q also true. Anyone having any objection, please let me know. It's a very, very interesting one. These are very, very interesting things. These are very, very interesting things. These are very, very interesting things. P and Q true, so P true. P and Q true, so Q true. If P true, left true, right also true. So I think these are everyone, no? These are all are valid. Little doubt also you ask me, I will explain. Sir, I have some doubt. Little doubt also that you ask me, I will explain. Little doubt also that you ask me, I will explain. Yeah, perfect. I feel that everyone is comfortable. Now can you try this problem? Now can you try this? S1 statement. Can you try this one? S1 statement. Negation P RQ. Negation P RQ. End operation. Between every two premises, there is an end operation. R goes to S. End. P R R. implication, negation S, implication Q. Is it valid or not? Verify. That is the S1. S2 also. Q and R. Implication P. End. Negation Q, R P. End Q. Implication R. Yeah, try this problem. You can try. It's a nice problem. You can try this. Valid or not? Valid or not? Try. If they are valid or not, try. I will give the answer. You please, you people can try this. If you want, you can apply implication rules. Implication rules, you can use it. You can use implication rules. You can use implication rules. I think there is no capital, there is no smaller. So if you want, you can write. If you want, I will write everything capital. Everything capital. Actually, everything capital only. It is R. Everything capital only. So you may be thinking that two R's are there. No, one R only. I want to say that only one R is there. Only one R is there. Yeah, let's go ahead and check. Let's go ahead and check. Let's go ahead and check. Yeah, let me try this one. Let me try this one. I am using another color. I am using another color. Can you see this one? This can be written as PRQ. This can be written as PRQ. So here P. These two people, if you observe, these two people, if you observe, P employees and P cancel. So which is going to be Q R R. So I think these two people, if you combine, RR cancel. RR cancel. So this can be written as RRQ. RRQ. So then this R and this R both cancel. So remaining is going to be S RQ. Check once if I done anything wrong. QRS. 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 So now let me try this one. So directly it may not be. If you write the another meaning, negation S becomes S, S or Q. So these two will be equal. These two will be equal. We know the formula also. P implies Q is equal to, right? Negation P or Q. You know this very well. Same thing I done. Negation S is there. If I keep again negation, S is there. S or Q. I think both are same. So S1 is a valid statement. Implication rules I applied. Implication rules. I am not done anything. I done the implication rules. Yesterday we discussed yesterday. If anyone is not getting, please check one time. So S1 is a valid statement. Try to understand. S1 is a valid statement. Let's go to S2. Careful S2. Anything we can do, check. Anything we can do, please check. So I will recheck once again. Is it same or not? Any small change there, I will do that. Q and R implies P, okay, and negation Q R P and Q. Yeah, I think this is one small mistake. So remember, this is not there. This bracket is not there. Sorry for that. S2, this is like that. S2, this is like this. Yeah, this is the S2. I'm really sorry. Yes, S2, can you re-verify again? S2, can you re-verify again? S2, can you re-verify again? Because I done small change. In the S2, I done small change. Can you re-verify again? Make it fast. S2, can you re-verify again? S2, can you re-verify again? Check one time. S2, can you re-verify again? So I'm trying now. S2, I'm trying S2. Check everyone. I'm trying S2. So this can be written as Q implies P. These two cancel. Right? These two cancel. So left out is P. Left out is P. Now, can we do anything for this? Can we do anything for this? So remember, Q true, P also true. Q true, so P also true. Right? So substitute there. This is true. If you can apply implication rules, well and good. If you cannot apply, that is also okay. There is no problem at all. So worst case, we can go to our procedures. Let's check here. So Q is already true. So from these two, I proved that P is true. Q is already true. From this, I got to know P also true. So P true, Q already true. So what can be R? R can be anything. So we cannot apply any implication rules. If implication rules possible, you go ahead. Implication rules are not possible. Implication rule is not possible. Normal way also you can do. So what can be R? R can be anything. So because if the left one is false, no problem. If left one is false, no problem. False implies P, which is true. So finally there is no problem. So R can be anything. He is saying that R should be true. Need not be. It is not valid. It is not valid. If anyone having doubt, normal way also you can check. If anyone having small doubt also, normal way, I done the mixed. The purpose of this problem is sometimes you have to do mixed. Sometimes you have to do mixed operation. Other than this, nothing there. Sometimes you have to do mixed operation. So it is invalid. So it is invalid, mixed operation. See, whichever possible do using implication rules. Whichever possible do implication rules. See this one. Second one, third one, implication rules possible. I done it. So Q already true. In the given data, already Q true. From the second one, third one, I got P also true. Substitute there. So P true, right? Already Q also true. So remaining thing is what about R? R can be anything. So not valid. If you want, you can do. If you want, you can do. Normal way also, no objection. Normal way also you can do. Some people are asking, sir, normal way how, sir? Whatever we done initial problem, similar way. If you want, I will do one time. Q and R. Only for namesake I am doing. You done, see, it is a mixed do. Some are using implication rules, some are doing a normal way. So I am doing directly normal way. I am doing directly normal way. So this one, so assume left is true. Assume left true. If left true means this should be true. This should be true because it is the end operation. This should be true. Right? So this, right? So and one more, Q already true. See correctly, Q already true. That one you substitute here. It is a true. So P should be true. So the conclusion what you got from these two people is, so P true, Q true. These two things substitute here. So Q true, P also true. So this is can be anything. R can be anything. R can be true also, R can be false also. So that is the reason. So I cannot give guarantee. I cannot give guarantee. This will goes to R. I cannot give guarantee. Means this means R is true only. No. R can be anything. Either true also, false also. So not valid. He is saying that finally R is true. Need not be. R may be true, R may be false. R may be true, R may be false. So you can do directly also. So I used some implication rules. If you want to use implication rules, use. It is not necessary everywhere I will apply implication rules. Sometimes possible, maybe I don't know how to use. Maybe I am unable to predict, I am unable to see where I can apply implication rules. Whatever possible implication rules you apply. Wherever implication rules possible, you apply. Total problem possible, do. Either at least half problem possible, use. Whatever possible, apply. Instead of doing blindly like this, implication rules, if possible, apply. Need not be total. If you want to apply in the few places implication rules, you can apply. See, in the place of these two, I can write only P. So this entire thing I can write as only P. Second one, third one. Combinedly, I can write it as P. Combinedly, I can write it as P is true. So Q already true. So by using second one, third one, I proved P also true. Finally, P true, Q true. Substitute those values in the first one. I got to know R can be true also, R can be false also. So it is invalid. It is invalid. I think many people are comfortable. Maybe initially you got some doubt. Now you are comfortable. S2 is not valid. S2 is not valid. Perfect. Let me know if anyone having any objection. Now next problem you can go. 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 I think S1, S2 you done. One more problem you do. Valid or not? Valid or not? S1. Valid or not? S1. Negation P R Q. And R goes to S. And P R R. Implication. Are we done this problem yesterday? Check. Sorry for that. Sorry for that. This is the previous problem. It is a previous problem. Sorry for this. Yeah, I'm changing it. Next problem I'm trying. Next problem I'm trying. S1. Negation P R Q. And negation Q P R R. Implication negation R. That is the S1. Can you try similar way? S2 also is given. S2 also you have to verify. P and P employees R and Q R negation R goes to Q. Yeah. So this is the next problem. So do this also. Iron, try this also. Iron, try this problem also. Yeah, go ahead everyone. Go ahead everyone. This problem. So valid or not, verify. Valid or not, verify. Check one time. Is it valid or invalid? Everyone try. See, if possible, apply implication rules. If possible, apply implication rules. Everything you want to do by implication rules, do. You want to do everything by implication rules, do, no problem. So if you cannot do, at least few you can apply implication rules. That is also okay. Worst case, suppose implication rules you are unable to apply, do normal way. Do normal way. There is no problem. Do normal way. Try one time. Everyone try, everyone try. Yeah, I will give the answer. Many people may be done, so I will give the answer. Can you see this? Can you see this one time? Yeah, if possible, apply implication rules. No problem. If possible, apply implication rules. If not possible, normal way also you can do. So I think a few minutes back I done some implication rules. Can you see all of them one time? Can you see this? Can you see these implication rules one time? Careful, careful everyone. Can you see these implication rules one time? Right? These implication rules one time you can see. They may be useful to you. They may be useful. Can you see one time? And in the previous class we done some implication rules also. I'm trying one time. See this one? I'm trying one time. So this one everyone know. This one everyone know. P implies R. So both cancel. It is R. So from these two people, so finally R came. These two are given R. Right? So, and one more. This one, if you observe clearly, negation R, RQ. This is nothing but R goes to Q. So R goes to Q and R both cancel. So Q there. So correct. So S2 is correct. S2 is correct. Check if you want. S2 is correct. Now go to S1. Go to S1. S2 is true, okay. Right? Go to the S1. If possible, apply implication rules. If not possible, do normal way. If not possible, do normal way. So it will goes to PRQ. It will goes to PRQ, right? We'll see that. We'll see. I think if any implication rules possible, please check. If not possible, we'll do now. I think people got to know this one. This is almost like a transitive property. It is almost like a transitive property, which will goes to P goes to transitive property, right? P goes to P employees are. These two will be cancelled. P goes to, right? These two will be cancelled. P goes to whatever is left out. P goes to PR. So everyone know if P true, see this one. If P true, careful, try to understand. Whatever it is also same. If true, it is also true. So what about R? What about R? Let's check here. If P is true, this is also true, right? So if it is false, yeah, we have to check some table for this. You have to see some table. I will check once. So P employee, right? P employees are. You check if anything is possible. Let me try. I want to make sure it should be negation R. I will check. So if the P true, this is also true, right? So assume that it is also true. Negation, right? T R is true. Then true, overall become true. No problem. So remember, R is true means negation R is false. R is true means negation R is false. But he's saying negation R is true. That is the reason it is invalid. So if you take the P as true, so you know very well, if left hand side, if we assume true, right should also be true, but unfortunately it became false. So remember, so what I am doing is, wherever possible implication rules I am applying. Wherever possible I am applying implication rules. See, trans2 property I applied. P implies Q and Q implies something. So Q both are cancelled, P employees, right? P employees are. Now I am checking, right? If this is true, negation R should also be true. When I checked here, I got to know that negation R is false. But he is saying true. So it is invalid. It is invalid. So implication rules sometimes, right, will simplify the total expression. If not, few things you can minimize, remaining things you can do normal way. Whatever possible, you can use it. If not possible, do normal way. So first one, second one, if you do combinedly, I got this. First one, second one, if I do trans2 property, I got this. Now this one, I don't know how to proceed, so I started substituting. So remember, I want to prove left true. Assume left true, then you have to prove right also true. By assuming left as true, so I got to know that R will be true. R will be true means negation R is false, but negation R is saying true. That is the reason invalid. Normal, it is a normal way. So S1 is invalid, but S2 is valid. S2 came so easily, S1 came little difficult. S2 came so easily, S1 became little difficult, but it is also normal one. You can check. Someone is saying that P goes to P employees are, right? P goes to P employees are. Is it true? Right? R should be true. Right? R should be true. But unfortunately, he is saying negation R is true. That is the reason wrong. S2 invalid. S2 is valid. S1 is not valid. Exactly. S1 is false. S2 is true. Exactly. Right? So P goes to P employees are. So when I verified by assuming left true, I am trying to prove right also true, but unfortunately right is false. What is the right? Negation R. Negation R is false. Right? But he's saying negation R is true. That is the reason S1 is false, S2 is true. Okay. I think people got it. Any objection, you can let me know. Worst case, you have to apply normal way. Right? So I'm giving the final conclusion. Everyone listen. I'm giving the final conclusion. Everyone listen. If possible, see this one. If possible, careful. If possible, total problem. Apply implication rules. If possible, total problem. Apply implication rules. If possible, do. Right? If possible, total problem, apply implication rules. Right? So next one. So that is the one thing. Suppose total problem not possible. If half problem only possible, implication rules apply. remaining problem apply, and the remaining problem apply. Normal way. Yeah, worst case. Suppose this also not possible. Apply total problem normal way. Normal way means assume. Normal way means assume, everyone know. Assume left hand side true. Prove right hand side true. Right hand side false. Prove left hand side as false. This is the normal way. Apply total problem normal way. First to try this. If not, try this. Lastly, do this. Apply total problem normal way. That is the purpose of this. So initially, I explained to you normal way how. Right? Apply total problem normal way. What is the normal way? Assume left hand side is true. Prove right hand side also true. Assume right hand side is false. Prove left also false. This is the normal way. If possible, do this. Suppose only 10% is possible, do 10%. Remaining you can do normal way. What is normal way? Normal way means this. This is the normal way. This is the normal way. Whatever possible. You can do mixed also. You can do mixed also. Mixed also you can do. You have to do practice. Please remember, if class notes you are okay. If class notes you are okay. Most of the PYQs you are okay. Most of the PYQs you are okay. You are going to get a very nice rank. Try to understand everyone. Class notes okay. Then definitely most of the PYQs you are okay. Most of the PYQs you are okay. Right? Then I think you are going to get a very nice rank. Please practice first notes. Please practice first notes. If you are not okay with the notes, it doesn't matter what you do further. Please be comfortable with the notes first. Please be comfortable with the notes first. If you are okay with the notes, you are okay with the PYQs, you are okay with the final exam also. First, notes is important. Be comfortable with the notes. Now come to the next story. Come to the next story. Everyone listen. Everyone listen. Next story. Everyone listen. Next story. So next story name is predicate logic. Next story name is predicate logic. So in that first portion is first order logic. First order logic. Previous one is the propositional logic. This is the predicate logic. Predicate logic first topic is first order logic. Predicate logic first topic is first order logic. It is the only there. It is the only thing which is there in the syllabus. Predicate logic first topic is first order logic. This is the thing which is there in the syllabus. Propositional logic, first order logic. These two are there in the syllabus. So we are going to cover the first order logic now. We are going to cover the first order logic now. Right? Fine. Yeah, can we start now? Can we start? Can we start now? Please check. It's a very important one. It's a very important one. This one also, if you can cover. This one also, if you can cover. Right? In the mathematical logic, you are going to get full marks. If you can cover this also in the mathematical logic, you are going to get full marks. You may get 2 to 4 marks. You may get 2 to 4 marks. Try to understand. You may get 2 to 4 marks. Everyone try to understand. You may get 2 to 4 marks. Everyone try to understand. Can we go ahead? Can we go ahead? Yes, no, check. Yes, no, very fast. Yeah, can we start now? Can we start the first order logic? Can we start the first order logic? Yeah, I'm starting the first order logic. First order logic contain, there are two symbols. Mainly first order logic contain, there are two symbols. Right? Predicate logic, which internally contain first order logic, which contain two symbols. So remember, those two symbols are, careful everyone, those two symbols are, first one, there exist. There exist. Second one, for all. First order logic contain, there are two symbols. There exist for all. There exist means people used to write like this. There exist. For all means people used to write like this. For all. This is existential quantifier. This is existential quantifier. This is universal quantifier. Everyone, for all means universal. The universal quantifier. There exist and for all. So remember, this topic mainly discuss about two things. There exist and for all. This topic mainly discuss about two things. There exist and for all. There exist for all. Symbols also I written. There exist is called existential quantifier. Existential, there exist. Right? When you say for all, universal quantifier. When you say for all, means universal quantifier. It should work on all. But when you say there exists, it will work on a specific thing. Yes, right? It is working on a specific thing, that is called existential quantifier, or there exists. Working on all, that is called universal quantifier. Working on all is universal quantifier, right? Working on only few, that is called existential quantifier. Right? I think you will get to know within few minutes all the details. You will get within few minutes all the details. Let's see. Right? So few domains. You can write whatever domain you want. I am writing two domains. Domain D1, domain D2, two domains. Domain D1, domain D2, two domains are there. Two domains. Let's see first domain. Let's see. So first domain, if you see, Salman Khan, Dhoni, Kohli, I think I can say now. Yeah, Let's go for Ananya Pandey. Ananya. So if you see the domain D1, Salman Khan, Dhoni, Kohli, and Ananya. If you see the D2, see this one. If you see the D2, Salman Khan. So I think Shah Rukh Khan. I think I can say Ananya. So I think Deepika. Right? Perfect. Now see, I think two domains I written. Whatever I felt I written. Nothing wrong in that. Whatever I felt I written. Domain D1, domain D2. Two domains are there. Whatever I felt I written. Right? Nothing specific here. Whatever I feel I written. Let me write now. Let us assume a of x means, let us assume that a of f, a of x means x is an actor, or x is a actor, right? A of x means x is an actor, or right? Remember. Now understand. Everyone try to catch it. Everyone try to catch it. For all x, everyone listen. For all x, for all x, for all x, a of x, for all x, a of x, and one more, x belongs to D1. Understand this. What is the meaning? For all x, a of x, where x belongs to D1, domain D1. That means everyone understand. That means if you take the first x, for all x means what? Every x you have to take. Every x you have to take. Take the first x. First x is Salman, right? See this one. First x is Salman. Everyone try to understand. Everyone try to understand. Salman is a actor. Salman Khan is a actor. Yes, true. Okay. Remember, for all means what? Everyone it should work. End operator. When you say for all, end operator, everyone should work. First one is working. Okay. Let's go to second one. A of Dhoni. Dhoni is a actor? No. So end operator false. So everyone know. End operator. One fail also, fail only. No need to go further. But if you want, you can go further. But anyhow, fail already. Next one. A of Kohli. Kohli is a actor? Kohli is a actor? No. It is also fail. Next one. Ananya is a actor? Ananya is a actor? Yes. Ananya is a actor. Right? What is the answer? It is a true. But remember, one fail also, fail only. Totally fail. So some people are asking, sir, what about the same thing on domain D2? Can you see this one? For all x, a of x. For all x, a of x, where x belongs to D2. Now understand. Some people are asking, now say, can you help me now? A of Salman. Salman Khan is an actor? Yes. And Shah Rukh is an actor? Shah Rukh is an actor? Yes. And Ananya Pandey is an actor? Yes. And Deepika is an actor? Yes. So overall, all are true. Finally true. So remember everyone. For all means for every person it should work. For all means for every person should work. When you say for every person, end operation. When you say every person, end operation, everyone should work. When you say everyone, end operation, everyone work, then only work. Some people are asking, sir, what about domain D1, right? There exists operator. Let's see. I'm doing that also. Can you see this one? There exists, everyone understand. There exists x, a of x, where x belongs to D1. Now, if you observe clearly this one, can you see this one? A of Salman. Salman is a actor. Yes, true. Remember, there exist means once. What is the meaning of there exist? One person is there, it's okay. Means that is R operator. Anyone true. Anyone true. That is the meaning of there exist. There exists a person who will protect me. In this entire world, there exists a person who will protect me, my mama. In this entire world, there exists a person who will protect me, mama. There exists a man who will protect me, papa. In this entire world, there exists a woman who will protect me, mama. There exists a man who will protect me, papa. What is there in that? Same thing here. There exists means one person is enough. A is right. Yeah, A means actor. So Dhoni is a actor. No, fail, no problem, because it's R operator. R. Kohli is a actor. R. Kohli is a actor. No. R. Ananya is a actor. Yes. But remember, one true also true only. One true also true only. Let's see one more domain. Domain D2 also I am trying. There exists a X where A of X is true, where X belongs to D2. Salman. Yes. Shahrukh. Yes. Ananya. Yes. Deepika. Yes. Okay, perfect. Perfect then. Perfect. Check once. Remember nothing. There exist means. There exist means. Remember everyone. When you say there exist, right? One person is enough. At least one person. When you say for all should work. When you say for all should work. Remember, in the predicate logic, there are two topics: first order logic, second order logic. In the syllabus, only first order logic. First order logic internally contain two symbols. There exist and for all. There exist, it's called existential quantifier. For all means universal quantifier. Name itself saying universal. All should work. All should work. Universal means all should work. When you say existential, at least one enough. At least one should work. All should work, that is called for all. Existential, at least one will work. When you say at least, right, R operator. When you say all, end operation. All should work. All should work. See, total society will be like this. Every time you are correct. Every time you are correct, then only you are a correct person. This is the nature of the society. Nature of the society is every time you are correct, then only you are correct. One time also you are wrong, right? Total society will blame you. So what I mean to say is, society always will think like a, right, for all. Right? Society will think like a for every time you should be correct. Every time, one day fail also fail only. So society is like, right, universal quantifier. Society is a universal quantifier. So family is a existential quantifier. In the family, if you do one time good also, they feel so good. In the family, you are good one time also, right? They are very happy. But you never satisfy the, right, total world. Universe you don't satisfy, because they are eagerly waiting for when you are wrong. Total society eagerly waiting when you are wrong. One wrong also wrong according to society. According to society, one wrong also wrong. You just show one wrong, so total society will blame you. But when total society is blaming mama, papa, your family trying to protect you, because they knows that you may be done one wrong. They know very well about their kid. Even total society saying he is bad, he is bad, he is bad, but family will protect you. Family will protect you because family knows what exactly you are. But right, society never bother. Right, everything correct, everything correct, everything one wrong gone. So society is universal quantifier. Family is existential quantifier. If you do one thing right also, family will be very happy. One time, first class, see, LKG fail, they don't have any problem. UKG fail, they don't have any problem. Fifth class fail, they don't have any problem. Ninth class fail, they don't have any problem. 10th class pass, they will celebrate. Again, 11th fail, no problem. 12th pass, again they will celebrate. So what I mean to say is a family is a right existential quantifier. Society is a universal quantifier. So society always look for, can you do one thing wrong so that you are gone? Can you do one thing wrong so that you are gone? Yeah, I think R symbol. Yeah, true. Right, these are R symbols. Yeah, you are correct. Maybe in the flow I written, so I'm changing it. Yeah, thank you for informing. Right, perfect. So can we move to next? Can we move to next? Bro, can we move to next? Can we move to next? Can I go to next? It's a very important thing is coming. Very important thing is coming. Can we go to next? Very important thing. Very important thing is coming. Can I go next? Now understand everyone. Everyone try to understand. Very important thing is coming. It will make sure are you really comfortable with this topic or not. Can you see this one? Can you see this one? If someone will say positive integers, if someone will say positive integers, if someone will say positive integers, if someone said to you positive integers, this is the meaning of positive integers. If someone will say negative integers, right? Positive integers means 1 to infinite. Negative integers means -1, -2, -3, -4, and so on, minus infinite. Okay, that is okay. But so if anyone say integers, if anyone say integer, it is going to be minus infinite, -3, -2, -1, 0, 1, 2, 3, and so on, plus infinite. So this is going to be negative integers. This is normally it is called as z minus. This is going to be positive integers, z plus. Total is called as z. Am I right? Okay, till now is it okay? Till now is it okay? Positive integers, negative integers, integers. Till now are you okay? Z plus, z minus, and z. Z is set of integers. Z is set of integers. Yes, can I go further? Z minus negative integers, Z plus positive integers, simply Z set of integers. Okay, now very important thing is coming. Now very important thing is coming. Can you see this one? Today's class, this is the highlight. Today's class, this is the highlight of today's class. This is the highlight of the today's class. Please catch it. This is the highlight of the today's class. Please catch it. Everyone, please catch this one. This is the highlight of the today's class. Right now, I am starting. Everyone listen. Everyone listen. Everyone have to listen. S1. For all x, there exists a y such that, this is a very important one. I am keeping star also. If you know this, you got the full marks in the predicate logic. You will get the full marks if you know this. This is a very important one. This is a very important one. See how many stars I am keeping. That much important here. That much important. From now onward, this statement will dominate like anything. From now onward, this statement dominate like anything. Everyone try to catch it. Everyone try to catch. See, not 1 star, 2 star, many stars. Many stars I am keeping. This is a very important one. Very important one this is. So see this one. For all x, there exists a y such that x plus y is equal to 7 in the domain of integers. In the domain of integers. For all x, there exists a y such that x plus y is equal to 7 in the domain of integers. Okay? S2. There exists a y for all x such that x plus y is equal to 7 in the domain of integers. Take this problem, and now our goal is we have to identify which are valid, which are invalid. It's a very important statement. It's a very important statement. For all x, there exists a y such that x plus y is equal to 7 in the domain of integers. There exists a y for all x such that x plus y is equal to 7 in the domain of integers. Now understand everyone. Understand everyone. Please, this is a very important statement. Very important statement. See this. In the S1 and S2, we are starting. Listen. In the S1 and S2, there exist means one person or many. I want answer. Please help me, everyone. There exist means one person or many. Understand everyone. Everyone try to understand. There exist means one person or many. One person is there enough, right? There exist means one person there enough. Remember, there exist means one person. I am giving one clue also, please remember. There exist means one person. Can you help me now? There exist means one person. In the S1, S2, where is the one there? In the S2, one is there starting itself or not? There exist means one person. There exist means one person. But in the S2, that one is there starting or not? There exist means one person. But that one is there in the S2 starting or not? I'm repeating once again. There exist means one person. In the S2, That one person is there starting or not? Remember, starting only condition. In the S2, there exists their starting. There exists means one person. Starting only one person. What is the meaning? I think remember. So in the S2, condition happens starting only. That too, one, there exists means one. One is there at the starting only. What is the meaning? One person fixed. But in the S1, right, starting is not there exists to. Starting is for all. There is a flexibility. So remember, there exists starting means, right, some condition is there. One person condition starting only. What exact meaning? Let's see here. See carefully, everyone. S1. What is the meaning of this? S1, S2. Carefully understand. S1, S2. In the S2, there exists happened starting only. Right? There exists means one person. There exists means one person starting only there. So that means, right? Remember everyone. Remember everyone. X1 plus Y. X2 plus Y. X3 plus Y. Remember, starting only there exists a Y, starting only. So starting only one means what is meaning? Y is fixed, and so on. Xn plus Y. Remember, X is keep on changing, because if you observe S2, there is a for all. See, for all X there, for all X. What is the meaning? X is keep on changing. But see, there exists a Y starting only. Y fixed. Y is fixed. Y you cannot change. Y you cannot change. Remember, X and Y belongs to in the domain of integers. But can you see the S1? Can you see the S1? In the S1, there exists there not starting afterwards. It means here nothing is fixed. That means X1 plus some Y1. X2 plus some Y2, X3 plus some Y3, and so on. Xn plus some Yn. This means in the case of first one, right, there is a flexibility. In the case of second one, no flexibility. Can you help from the set of integers, x1 plus y1 is equal to 7. If you take x1 as 1, y1 is 6, 7k. If you take x2 as 5, right, y2 2, I think 7k. If you take x3 as minus 100, because he said set of integers, so this one may be 107, total 7. This one may be 500. This one may be, right, I think 500. It may be 507, which is going to be 7. But if you see the second one, remember everyone, see this one. 1 here, it is a 6. But here, if I take 2, still 6 only. If you take 3, right, still 6 only. I think it is wrong. It's wrong. Remember, here also for all there. Here, because of for all, understand everyone. Because of for all should work. But in the second one, right, there, right, Y is fixed. In the second one, Y is fixed because Y came starting. See, starting itself a condition. Early morning condition. If early morning itself condition, you cannot do anything in life. Have flexibility. Have at least early morning, have flexibility. So starting itself condition, no one can grow. You have to give the chance to, right? Every parent have to give chance to the kids. Falling, starting, you fall, no problem. We are there. We are there to help you. You can fall, no problem. You right? So just walk. If you fall also, no problem. We are there. Starting itself, you cannot fall. I will beat you if you fall. Then no one will stand also. Early morning you kept a condition, right? You cannot fall. You have to walk straightly. You cannot fall. If you fall, I will beat you. Then no one will walk also. You have to say, if you fall also, no problem. Come, I am there. If you fall also, no problem. Come, I am there. So in the case of the S2, starting itself condition. So why fixed? So I think definitely. But remember, here also for all, there, here also for all. Everyone should work. See, everyone working. End operator. Overall true case. But here, see this one, here also end operation. Here also end operation. So first one is right, first one is true. Second fail. Third fail. Right? So fail. So overall fail. Overall fail. So first one is a pass statement. Second one is not a pass. Remember, in the first one, flexibility there. In the second one, no flexibility. Here, flexibility there. X also can change, Y also can change. Here, no flexibility. Here, no flexibility. Fine, I think everyone is comfortable. I think everyone is comfortable. It's a very, very important one. Total predicate logic, it is a major one. Total predicate logic, it is a major one. Major one, this only. If anyone say mathematical logic, I am not getting. If anyone say mathematical logic, I am not getting. Say to them, please see this first. Please see this first. Mathematical logic, I am not getting. Say to them, please watch this. Please watch this. Please see this. Please see this, then automatically they will get. Some people are asking, sir, in the S1 also one for all, one there exists. In the S2 also one for all, one there exists. Yes, true. In both of them for all there exist. But in the S2, there exists starting only. There exist means one. One means fixed. Y is fixed. Right? After some time condition, okay. Starting itself condition, not okay. Y fixed. See, same Y. Everywhere 6 only. Everywhere 6 only. But here there is a liberty. Not fixed. I think everyone got clarity. We done really today nice work. Please go through all of them one time and tomorrow come. So from here onwards you take care. From here onwards you take care. Right? So this from here onwards you please take care. So one example I given. Tomorrow total class on this only. Total class on this. Total class is on this only. So if anyone is not started, my request is, it is the last batch. Last batch of GATE 2026 is going on. Just started. Discrete mathematics is started. You can use the code EPT 595 ARG. 80% discount going on. Today is the last date. For this offer. So within I think in my opinion 5 more hours. Within 5 more hours this offer will be gone. If you are serious, you can join. Go to Exampreptool.com. Right? You can take the regular course, which is the 1 year, foundation course, which is the 2 year, crash course, which is the 6 months course, right? RIC course, practice course, or test series. You can take whatever you want. One more offer going on. If you buy one, you will get 3. One more offer is going on. If you buy one, you will get the 2. So there is offers are going on. Please check. Those are called combo offers. You can utilize them. So thank you so much. Thanks everyone. Thank you so much. See you in the next class. Tomorrow is the last class in the YouTube. Tomorrow is the last class on YouTube. Tomorrow is the last class. Right? Afterwards, classes will be there on the EPT. Tomorrow is the last class. Right. Perfect. 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 Let me know if anyone having any objection. Yeah, tomorrow is the last class. If anyone is not started the preparation, please start at least now. Thanks. Thanks everyone. See you tomorrow. Yeah. Bye. Bye. Good night. Good night, everyone.